All right, adventurers, welcome to the last video for floor 6. So just to recap, in the first video, we got our stack working. In the second video, our isBalanced function uses it. Our self-test on stack is all green, and our lint returns real answers. In this video, we're going to finish this floor with undo. Then we're going to do us a little exercise that reveals the stack that's been under your feet all the way, the call stack. And we're going to do one permanent edit today. It's going to be one. We're going to work on the body of the undo dispatcher in main.cpp. We're going to have the take and sort commands have been pushing undo action snapshots onto the hero.undo stack since the first video. Record undo was wired up from the start for us. Now today our undo is going to actually finally replay them. And then we're going to do the little no code just segment in Notepad. We're going to take floor 1's binary search recursive and rewrite it iteratively with an explicit stack of type range. Nothing is going to be checked in for that. The walking through it is the lesson there. Now the main thing to think about here, and one key hazard, is we want to bind our references to the top action before we pop when we're working with this stack here. Our pop will destroy the front node. If we pop first and read after, we're reading actually from freed memory. And so that's the same shape of bug we're going to see when we get into floor 7 on the last video there. Now, let's go ahead and get started and let's build and kind of pick up where we ended last time. Because right now we're going to see once this loads up, we're going to have a button that does nothing so far. So let's load this up in here. And we're going to use the take command. If you notice, we have take and then in angle brackets name. So we can take a small item by that name to your inventory. Or add a small item by that name to your inventory. I'm sorry. So it's okay. I want to take the lantern. So you see it says taken lantern. Okay, cool. So weight 1, value 1. And then I can say undo. Right, not yet implemented. So our take works, and it has been quietly since the first video for this floor. Take has been pushing a snapshot of our inventory onto a stack ready to be undone. But undo itself is still just a stub. The memory is being recorded, but nothing can replay it at this point. So today we're going to write the replay, which is going to be about 5 lines. And then I'm going to show you that the most important stack in your program is one you have never declared. So let's open main.cpp now, and let's find this command here. Okay. We close that. Let's go to our main.cpp. Perfect. And let's go ahead and rock and roll here. Okay, let's scroll on down here to our undo. Let's find our undo command branch here. There's our take, sort, undo. Okay. We'll kind of delete some of these comments too, just to get all this out of my way. You don't have to delete them, of course. But there we go. Okay, gotta get this thing going on here. Okay, so right now you see it says standard cout undo not yet implemented. We need to implement this. So I'm going to delete this line right here, of course, and we're going to get going here. So what I want to do first of all is to say if our hero.undo stack dot empty. Okay, if that is true, then I'm going to go into this branch here and I'm going to say, okay, we'll say standard cout. We'll say nothing to undo as such. Otherwise, if it's not empty, then we're going to say, I'm going to say const undo action. We're going to say ampersand a is equal to hero dot undo stack dot top. Okay, so we'll grab the top. And then we'll say hero dot inventory equals a dot inventory snapshot. Okay. And then I'll say standard cout. I'm going to say undid. We'll do a.description. And we'll do our backslash in there. Perfect. And I'll say hero.event log.push front. And we'll say undo, parenthesis, plus a.description plus close a parenthesis, and then semicolon, and then I'll say a hero.undo stack.pop. Okay, so what I think I said 5 lines earlier, right? So I promised 5 lines. There's that right there. Okay, let me see. I'm missing a parenthesis up here, looks like. Okay, there we go. So we got that working good. Now, first line, what we're saying here is if the stack is empty, say there's nothing to undo and then stop. This is the guard, and this is not optional in this case. Calling top on an empty stack dereferences null. That's what we call the hollow echo if you go and look on the floor 6 page. The monster that strikes when you read a stack that has nothing in it. So you want to always check empty before using top. The ADT does not protect you here. Your caller must. Now the else branch, and here is the trap. We bind a const reference to the top action. The const undo action ampersand a equals hero.undo stack.top. And we do it before we pop. Now, what we're saying is I need to read everything I need from it, copy its snapshot back over to hero.inventory, print its description, log it, then pop. If we popped first, A would be a reference to a node that pop front just deleted. You'd be reading freed memory, and it might even look like it works until it doesn't. Bind, use, then pop. The order is the whole bug, potential for the bug there. We have one bag assignment, so hero.inventory equals a.inventory snapshot. This does the restore because we gave bag a working copy back on floor 4. So let's go ahead and now let's build this. Perfect. Let's see. Okay. Perfect. So we're in here. I can then say, well, what's my inventory right now? Right now I have a rusty sword, a healing potion, an iron key, a loaf of bread, and a cloak of shadows. Well, I could say, well, maybe I want to add me a lantern. Okay, so let's say in the game I picked up a lantern. Maybe it's getting a little dark in the dungeon. All right. Do we have any fuel for the lantern? Maybe try to make it too realistic. Okay. So then I can say, well, let's sort our inventory now by weight, let's say. So in ascending order. And we notice there in position 3, we have our lantern. So it is there. Okay. I could undo. You see it says, okay, well, I just undid my sorting my inventory by weight. Okay. I could undo again. That means I just undid taking my lantern. I could try it again. You see, of course, there's nothing to undo. I can check my inventory again, and you see the lantern is not in the inventory. So you can watch the history rewind in reverse. I took a lantern. I sorted by the weight. 2 changes, 2 snapshots on the stack. First undo pops the most recent one. So the sort is reversed. The inventory is back in its pre-sort order. I then have our second undo, which pops the next, which the lantern is gone. So we're back to the original 5. And then we do the third undo. Of course, the stack is empty, and our guard says, hey, there's nothing to undo here, instead of crashing when it's checking top. So last in, first out applied to our own actions in our dungeon. That is undo in every program you've ever used, and it's a stack underneath every single time. Now, let's talk a little bit about recursion as a stack. Okay, so I pull this up a little notepad here, and let's just think about our binary search recursive that we wrote in the past, right? We essentially have a low and a high on that function where we then say, okay, if a low is greater than high, I then return not found, right? And then I say, okay, otherwise I'm just going to put a semicolon there. We're kind of doing some pseudocode here. Let's say otherwise our mid is equal to our low plus our high divided by 2. All right, then compare. Then recurse on low and mid minus 1, or mid plus 1 and high. Okay. And that's essentially our brackets there. See, I don't need that other bracket there on the end. All right, so that's essentially what we were doing there. Now, this is the idea I want you to take with you. Remember binary search all the way back on floor 1, the recursive version. Each call works on a range, a low and a high, and calls itself on a smaller range. When it recurses, where does the current low and high go? Well, they go on a stack, which we call the call stack. Every function call your CPU makes pushes to what we call a frame. And essentially that is its local variables, where to return to onto a stack. And popping that frame is how return works, okay? Recursion isn't magic. It's a stack you don't have to manage because the machine actually manages it for you, okay? So let's say if we think about just kind of stepping through this, let's say we say, okay, imagine you have a range here as a little struct. Let's say we have like an integer low, and you had an integer high. You could then make a stack given that range, right? That struct. We could then push the whole array's range to start. Then we could loop while the stack isn't empty. Okay. Like I said earlier in the video, a stack of type range. I should say a stack that is created given the struct of range. Apologize for saying that earlier. So then we loop while the stack isn't empty. Okay. We pop a range. We compute our mid. And instead of recursing, we push the subrange you'd have recursed into. Okay. Now, this is the same algorithm. Okay. So same algorithm. Let's just say that from the start here. And that, of course, big O notation would be O log of n. But now the stack is a variable we can see, okay, which is big. We can see, we can print, we can step through all of those things. Okay. And this is good because this is instead of frames hidden in the runtime. Okay. And that's really, if we want to be more philosophical, that's really the deep lesson of this floor. The stack we built this week by hand is the same structure holding up every recursive call you've ever written. You just made the invisible one visible. Okay? So, I hope this was helpful. Stepping back here, we had 5 one-line methods. 4 we wrote, 1 was provided, and with them we got a bracket checker that's a piece of every compiler, an undo system that's in every editor, and a new way to see recursion. That's the payoff of an ADT. The promise was tiny. What it unlocks for us is enormous. Okay. Now, one warning from Grix the Opportunist there. If you notice, he'll tell you the empty check before top is just more code. Call top and see what comes out. Don't. On an empty stack, that's the hollow echo, a dereference of null, a crash far from the actual mistake. Or worse, garbage that looks fine until it doesn't. The guard isn't paranoia, it's the contract talking. The ADT does not promise what top does on empty, so you check. So make sure to read the floor 6's page, the check for understanding section before our next floor. Make sure we understand the LIFO contract, the 3 data structures that could build a stack, and what the bracket balancer is doing. And if you listen now past the lectern, down a corridor of red and blue tiles, there's the sound of slow water and a long, patient line. Steward Quill keeps the cisterns. He doesn't remember the last thing said. He remembers the first one still waiting. Floor 7 is the queues, and I'll see you there.